Hi everyone. All right, today we're going to take some notes on Bohr models, and then you're going to work on making some your own or filling some out on your worksheet. So I need you to get out your notebooks and title a page in your notebook Bohr models right up here, just like it is on this slide. Bohr models is the title, and get your notebooks ready. So I'm going to give you a couple minutes, or not quite, I'm not that patient, but about a minute to get that out. So go, get it out. "30 seconds. Let's go. Get your stuff out. Get ready. Title your page Bohr models. Get ready to take notes." Okay, that's enough time. I'm a little impatient, sorry. All right, so let's get ready. We're going to take some notes here. All right, so remember that Bohr was the guy that discovered that electrons move in layers, or have layers, or what he called shells, or energy shells, okay, around the nucleus. And remember that he was close, that they do stay up in layers, but that they aren't in those perfect little orbits. So remember, when we're drawing these rings and creating these Bohr models, that the circles aren't orbits. Those are just representing the distances that the electrons stay at. And so some of the advantages of a Bohr model, and why we still use them today, is to help scientists kind of remember and work with the structure of the atoms of each element, as well as reactivity. It really helps kind of visualize the reactivity of the atom, and therefore how it's going to react with other elements, and so on and so forth. All right, so get ready. Here's what we need to start writing. All right, so rule number one, copy this down. Rule number one, where the element is on the periodic table tells you how to build the model. So that's one of the cool things about the periodic table. It sort of guides you into the Bohr model. So it's also another reason why the periodic table has got that funky shape to it. All right, so where the element is on the periodic table tells you how to build the model. All right, so let's say we're going to pick potassium, okay, which is K in that first column. So we're going to use that as our example throughout this lesson. All right, I hope everyone's got rule number one copied. If not, we can go back. We can pause the video, get it copied, and then restart the video. All right, so I'm moving on. Rule number two, copy this one down. Rule number two, determine how many protons, neutrons, and electrons the element has. So remember, we picked potassium, and so potassium looks like this on the periodic table. And if you remember, you should remember, okay, the atomic number tells us protons, atomic mass helps us find neutrons. So if we do all our rules, protons are 19, neutrons are 20, and electrons are 19. Now that's for potassium. Okay, remember, you subtract the atomic number out of the atomic mass to get your neutrons. Sorry. And then electrons and protons equal each other. All right. So let's go to rule number three. This is the next one. Make sure you copy this one down. Then you're going to have a space after this, so because you're going to draw your Bohr model in this space. All right, so rule number three, the nucleus is represented as a small circle with the proton number and the neutron number inside it. So make sure you give yourself a little bit of space, and you're going to draw a small circle because you're eventually going to draw some rings around this, so make sure that you have enough space around this, or put it on the next page. All right, so this is kind of what the nucleus of a Bohr model looks like. So P19 and N20, that means 19 protons and 20 neutrons. Okay, so that's how that one works. Let's go to rule number 4. Rule number 4, determine in what period the element is on in the periodic table. This is how many layers of electrons the element has. So remember, we picked potassium to begin with, so that K, and it was in the 4th period on a periodic table. So that's how many rings we're going to draw, or how many circles we're going to draw around that nucleus that we just drew for rule number 3. So rule number 4, determine what period the element is in on the periodic table. And this is how many layers of electrons the element has. All right. I know that one was kind of long to copy. You're going to have to write fast. Okay. Rule number 5. Rule number 5. Determine in what group the element is on the periodic table. This is how many electrons go on the last layer, or the outermost layer. Okay. So remember, we picked potassium, and it's in that first group. Remember, groups are columns. It's in that first group. So it's going to have 1 electron on that last layer. And if you remember how many layers, it should be 4, because potassium was in that 4th column. I mean 4th row. Oh, good Lord, sorry. All right, so rule number 5, determine in what group the element is on the periodic table. This is how many electrons go in the last or outermost layer. All right, rule number 6. The Bohr model has the same number of rings around the nucleus as the period number. So remember, potassium was in the 4th period. So remember, you wrote down this nucleus, add 4 rings around it. Draw 4 rings. 1, 2, 3, and then the last one, 4. Okay. So rule number 6, the Bohr model has the same number of rings around the nucleus as the period number. Okay, we ready next? All right, these rules should kind of lead up to how we're going to do this. So this next one, we'll start adding the electrons. So rule number 7, electrons start on the inside ring. Each layer can only hold so many electrons, but can hold less, and a lot of times they do. So you follow the pattern to add the electrons until you need to fill the outermost layer with the same number as the group number. Now I know that sounds confusing and it's really long to copy, but hopefully it'll make some sense when you get to this next one, when I show you basically. All right, so electrons start on the inside ring. So we're going to go on this inside ring is where we're going to start putting our electrons. And then there's a pattern to it. So level 1, which is the inside ring, can only hold 2 electrons at the most. Then level 2 can hold only 8 at the most. Level 3 can only hold 18 at the most. And then after level 3, levels 4, 5, 6, and 7 can hold up to 32 levels, or 32 electrons. Now you're going to see that potassium doesn't fill this in. It's going to do some more stuff. Okay, so you're going to see how this works, because remember, potassium's group number was 1, and it's in period 4. So it has to have 4 rings, and it has to end with 1 electron on the outside ring. So watch how we're going to do this. Okay, we know that there are 19 electrons in potassium because there's 19 protons. So the inside layer can hold is 2. So we're going to add those there. 1, 2. So add those to your picture on your notes. All right, so now we still have 17 electrons to go, right? So there's 2 there. We got to add 17 more. But the next level can only hold 8. So we're going to put 8 more. We still have 8, right? Because we have 17 left. So we can still fit 8. So the second ring, we're going to put 8 electrons. And it kind of goes in a pattern like this. 1, 2, 3, 4, 5, 6, 7, 8. All right, so there's 8 electrons plus the 2 on the inside. So now we're 10 electrons. How many electrons do we have left? Right, we have 9 left. Now level 3 can hold up to 18 electrons. But we know we have to have 4 layers of electrons. And that last layer has to hold 1. So here's how this works, okay? On the third layer for potassium, we're going to put 8 more. 1, 2, 3, 4, 5, 6, 7, 8. So now we have 1 electron left. So even though we could still fit that 1 electron in that third layer, we know that potassium has to have 4 levels of electrons with 1 electron in that outer shell. So did y'all see that? Okay, we added that 1 last electron. So potassium ends up with 2, 8, 8, 1. But it matches all of the rules that go with the Bohr model. That it has to have the same number of layers as its period, and same number of electrons on the outside shell as its group. So it's in group 1, we have 1 electron, and it's in period 4, we have 4 layers. 1, 2, 3, 4. Okay? So that's how that works. And if the substitute needs to come back and go back through some of these, they have the PowerPoint to pull up. They don't have to watch the video again. And then you can start working. Okay? Fill out your worksheet. Use your periodic tables. Don't have to do it without the periodic table. Use the periodic table and then create the Bohr models for the elements that are on or the elements that the worksheet asks for. Okay? All right, good luck. And if you get confused or totally lost, I will be back tomorrow. I promise. All right. I want you to try, though. Make sure you're trying. Because if you don't try, I'm not going to help you. All right. Bye, y'all. Behave.